We are from Group 4 and our topic is Anabasine. Our group member consists of me, myself, Siti Zakia binti Zakaria. We have Muhammad Ashraf bin Shaharuddin, Siti Nur Syaira binti Ismar, Muhammad Jamil bin Mansur, and Dayang Nur Azima binti Abang Zainuddin.
The origin of Anabasine. Anabasine was first isolated from the native Anabasis Aphelia scrub in Mongolia. It also occurs naturally in Nicotiana glauca, a wild tobacco plant and used as a biomarker for active tobacco use. The simultaneous detection and amount of nicotine metabolite, and Anabasine in a urine sample were used to classify an individual as non-exposed, non-tobacco use, and non-user of nicotine, passively exposed to nicotine or tobacco, active nicotine or tobacco user, obtaining from smoking for 2 or more of week, and active nicotine or tobacco user. Urine is the preferred specimen of a serum or plasma. For such analysis as serum or plasma, concentration reflect recent nicotine use compared to urine. Use of Anabasine as a plant insecticide can result in its release into the environment, and thus Anabasine may be present in consumable other than tobacco product. Anabasine is also known to be present in e-cigarettes that have been considered as an alternative to smoked tobacco. This indicates that Anabasine may not be specific to tobacco exposure. Anabasine is known to exert its insecticidal effect through interaction with nicotine acetylcholine receptor. Anabasine is the main alkaloid in N-glauca, and all the alkalizing effect of the plant are attributed to this compound. In N-glauca, Anabasine constitute 1.2% of the plant matter in the fruit and 1.1% of the plant matter in the leaf. Roots, flower, and stem contain less Anabasine. Anabasine is a colorless viscous liquid that turns brown with edge upon contact with air. It has a boiling point of 280 degrees Celsius to 281 degrees Celsius and is less volatile than nicotine. Anabasine freezes at 9 degrees Celsius. The compound is very stable, remarkable, basic in direction, forms in typical alkaloid manner, and it's soluble in water in all proportion and in most organic solvent. Physical and chemical properties of Anabasine. The molecular formula of Anabasine is C10H14N2. The molecular weight 162.236 gram per mole. The physical form is liquid, melting point 9 degrees Celsius, boiling point 270 until 272 degrees Celsius. Density 1.0455. Refractivity is 48.96. Water solubility 9.9 gram per liter, and for water it is very sparingly soluble. pKa strongest basic is 9. Decomposition, when heated to decomposition, it emits toxic fumes of nitrogen oxide.
According to Bunsuba et al. 2014, Anabasine is a pyridine-piperidine combination ring. And according to Celeranta and Lino 2011, a simple synthetic route to produce homoallylic amines can be achieved by using Barbier-type allylation of N,N-dimethyl sulfonamide protected aldimines. 3-pyridine carboxaldehyde, structure number 1, is the starting material for N,N-dimethyl sulfonamide protected 3-pyridyl aldimine, structure number 2. After that, it will undergo allylation in N-hydrous tetrahydrofuran and using zinc as a mediating metal. Then, the compound will be subsequently deprotected to allow efficient transamination procedure and produce pyridinyl homoallylic amines, which is structure number 4. These enantiopyridinyl homoallylic amines building blocks will be further transformed into dihydropiperidines by means of N-allylation or the ring-closing olefin metathesis. In the N-allylation step, 1 equivalent of the homoallylic amine, 1.5 equivalent of allyl iodide, and 3 equivalent of potassium hydroxide in anhydrous dimethylformamide will be used. Extraction with diethyl ether produce the diallylic products. The diallylic amine, structure number 5, were converted into salt with addition of one equivalent of p-toluene sulfonic acid (PTSA). With the subsequent ring closure, then the hydropyridine will be obtained. The diallylic amine, which now consists of one additional nitrogen atom in the pyridine ring, will be harmful for the ruthenium catalyst. Therefore, two equivalents of PTSA were needed for masking this compound. Only after this circumstance were applied, then anatabine can be obtained. Hydrogenation of anatabine, structure number 6, using palladium on carbon as the catalyst, will be proceeded to obtain anabasine.
Anabasine will be collected from the plants called Anabasine aphylla. The part of Anabasine aphylla that we're going to use is the aerial part. The powder aerial part will be extracted with 80% aqueous ethanol, obtaining ethanolic filtrate. The filtrate then evaporates to dryness, leaving an oily residue. The oil residue will dissolve in 2% citric acid before being extracted with chloroform, forming an aqueous chloroform layer. The aqueous chloroform layer was specified with the ammonia solutions with the pH 5 to 5.5, then be extracted with chloroforms. After that, it will again be specified with the 10% ammonia solution with the pH 8 to 9, and then be extracted with the chloroform again. The chloroform layers then will combine, filter, dry over anhydrous sodium sulfates, and evaporate to dryness. Up until now, we only get the fractions of the plants that contain anabasines. We still have to undergo a few more steps to obtain a pure anabasine. The fractions that obtained for last step then will show positive result with both Mayer and Drengodorf reagents. About 1 gram of the fraction was fractionated by passing through a column of silica gel using a mixture of silica gel and hexanes. Later, it was packed in a column with 2 cm diameter and 80 cm for a height. The column was eluted with hexanes, then with chloroform, then with the mixture of chloroform and methanol with a concentration of 1, 2, 5 and 10%. In here, we will collected around 7 to 10 ml of the fractions. Fractions containing anabasine were further fractionated by HPLC, high performance liquid chromatography on silica gel using the mixture of chloroforms, methanol and NH4OH solutions, with a fraction of 60 to 10 to 11 as the mobile phase. Through this way, anabasine managed to obtain through the isolation methods. This is the isolation method that we can use, one of the isolation methods that we can use to obtain anabasine from the plant of Anabasine aphylla.
Anabasine is the main alkaloid found in Anabasine aphylla L, used to combat agriculture pests. According to Prosnov and co-researcher 2012, Anabasine derivatives are synthesized using a limited number of methods such as alkylation, acylation, and others electrophilic reaction of the secondary pyridine amine. Many derivatives of Anabasine bearing different substituents on the nitrogen atom, including the acyl group, have been prepared. Many cinnamol derivatives have been recommended as drugs for the treatment or prevention of arterial and venous thrombosis, acute coronary syndrome, and others. Anabasine has been shown to interact with cinnamol chloride, and the product was manufactured with a low yield, around 45%. According to Nurkinova and her friend 2019, revealed the biology activity of the prepared alkaloid derivative. They perform primary screening of the antimicrobial and cytotoxic effect on the compound anabasine. Therapeutic value is related to the therapeutic properties of medication, their clinical effectiveness, and health outcome. Anabasine is a tobacco alkaloid that has been used as a biomarker of active tobacco use. Anabasine also contained in both licit and illicit cigarette is less variable than anatabine, and therefore anabasine considered a better measure of tobacco consumption. And a study was conducted to estimate the rate of anabasine extraction, which can be used to assess tobacco uses without using therapeutically prescribed nicotine.
Anabasine can be obtained by Barbier type allylation method through extraction, fractionation, and isolation process of the plant Anabasine aphylla aerial part. Besides that, chemists synthesize chemical compounds that occur in nature in order to gain a better understanding of their structures. Hence, the chemists, they synthesize chemical compounds like Anabasine so that they can better understand the structure for Anabasine. And then the synthesis of Anabasine, the Anabasine is chemically synthesized because it is used to make products in large quantity for industrial purposes, such as industrial insecticide, as Anabasine is widely used as insecticide. And our group has chosen a general procedure for the enantioselective synthesis of Anabasine that was proposed by Ayers and Ayers et al. In 2005. Synthesis of Anabasine is started by adding boron trifluoride diethyl etherate to a solution of 3-aminomethyl-pyridine and 2-hydroxy-3-phenadone in benzene. The reaction mixture is refluxed for approximately 2.5 hours under nitrogen gas using a Dunn-Stark apparatus. After cooling, the solvent is evaporated under reduced pressure, and the residue is then purified by flash silica gel column chromatography using CHCl3, hexane, and methanol in the ratio of 12:2:1 as the elution solvent to obtain 2-hydroxy-3-phenadone ketamine as white crystals after removal of solvent. So the reaction of 3-aminomethylpyridine and 2-hydroxy-3-phenadone to produce the ketamine 2-hydroxy-3-phenadone ketamine can be seen in the picture as above. And then after that, after you have done with the ketamine, dropwise lithium diisopropylamine, which is also known as LDA, is added to a stirred solution of ketamine in tetrahydrofuran, which is also known as THF. 1-chloro-4-iodobutane in THF is then added dropwise. The solution is then extracted with diethyl ether and washed with brine, dried over anhydrous magnesium sulfate, and then filtered, and lastly the solvent is evaporated. After you have done all that, the crude is added to the mixture of 95% of ethanol, hydrogen monohydrate, and acetic acid. The mixture was stirred overnight at room temperature and 10% aqueous sodium hydroxide solution is added. Hence, Anabasine is obtained as pale yellow oil, as shown in the bottle at the side there.